All right, so in this lesson, what we're going to do is we're going to introduce VDBs and then combine all of the elements that we've learned so far into a basic setup that we can then use to repurpose over and over to create a massive VDB library. To start, I'll just introduce you guys over to the VDB, OpenVDB. So it was a piece of software that was created at DreamWorks. And it quickly became industry standard. I think it was around 2012 or so when they introduced it into Houdini in Houdini 12 or so. The main reason why you use VDB is because it essentially is a lot more memory efficient. It's essentially a big problem that you run in with volumes is that the volume is not necessarily an organic shape like this, but it's a cube. It's a rectangular cube. And the problem with this is that any empty space holds values, and they might be values of 0, but they're still values. And the beneficial part of VDB is that if they are not out here, if there's no values out here, it just completely cuts them off. It doesn't even store them at all. So that's a huge overhead that is reduced from using VDBs. The downside of it is that you don't necessarily use them during simulations. So you often have to either convert them over. So while you're ever working in the geometry side of things, you want to try to stay with the VDB as much as you can, but you can always convert back and forth as you need to. And we'll chat about that as we go. So I'll start by just creating, before we get into this setup here, I'll start off by just creating a very simple VDB, and we'll kind of like talk about that. So I'll just start by putting in geometry. I'll just call this our VDB cloud. And I'll dive inside of here. I'll go ahead and drop down a sphere. And I'll go ahead and switch this over to polygons. And now what we can do is just type in VDB, whoops. There we go. And you'll get a big long list of stuff that you can utilize. And this is essentially the OpenVDB library. And what we're going to start with is the VDB from polygons. And this is what we're going to use to convert the sphere over to a VDB. So if we just make that visible, you'll see that we'll start to get some voxels. You'll see that we get this little pixelated looking thing. If we want to actually generate a volume from this, all we have to do is switch off this distance VDB to fog VDB. And then to control the quality of this, if we want this to be a little bit more dense, we can always control things with this voxel size. So lower values are going to be more detailed. And you can kind of see that we kind of have this bounding box here. And you might think this is going to be a traditional Houdini volume in the sense that it's storing both data values internally and externally. But if we do a VDB visualize tree, we'll see that a better representation of this. So the blue boxes are going to represent just where any value is stored. So instead of it storing all these values out here, it can just store these. And basically what that means is that now we can create much more dense volumes with much less memory overhead. Cool. So what if we want to start converting this from a VDB to volumes or a VDB to polygons or whatever? We could always do a VDB convert or convert VDB. And when we plug that in, what we'll see that is right now we're converting to a volume. We can convert back to a VDB. We can convert all the polygons. If you see this, we just have to kind of increase these values so that we can actually get a polygon result out of that. And then we can always convert this back to whatever we want. So there's that. So let's start working on building the actual detailed cloud setup that we can repurpose through our VDB library. So what I'm going to do is up on this sphere, what I'm going to do is start by setting my radius to 3, 1, and 3. So it's 3, 1, and 3. And what that's going to do is just make this an oval shape. I'm going to do a VDB from polygons. It's going to be a little bit too detailed for us right now. So what I'm going to do is just drop that down to 0.1, because essentially what I want to do now is utilize the technique that we were talking about in the earlier lesson and scatter some points through that and then go from there. So I'll drop down a scatter. And this time, instead of just doing one, what we'll do is we'll do a couple different ones with a couple different scale values. That way we're starting with a really organic looking base. And the force total count on this, I'm going to set to 50 right there. And then what I'm going to do is drop down a point stop. So point, plug that in, make it visible. We'll choose the scale attribute. And then of course we'll choose the random preset. And this time what I want to do is, instead of using this value, that essentially this is going to produce a random value for every point from a value of 0 to 1. And we don't necessarily want that, because some values might be 0.1 or 0.05, which will essentially get too small. So we want to use a fit expression to remap this value. So what we'll do is we'll throw a fit 01, which is essentially saying, that's the command right there. So fit 01, what that's going to say is fit this value, this random result, to a value between whatever values we say. And this time we'll say it's 0.5 and 1. So we're given a random value between 0 and 1. So whatever that be, so if it's a value of 0, if this produces a value of 0, it'll get remapped to 0.5. So they're not so extreme. Cool. And then what we'll do is we will just go ahead and copy and paste this. We'll go ahead and change this force total count to 15. We'll leave this 0.5, and then what we'll do is right here is change this to 2. We're going to do another one right here, but I just want to merge these in so we can see the results, so we can kind of see what's happening here. So I'm going to merge these together. So we're taking two different trees, this scatter setup and this scatter setup. I'm going to turn off my display and then go to background, just change that to dark, so we can see this stuff a little better, and turn off the grid so we can see those points a little bit better. So we got these guys, we got those guys, and then we're going to merge them together. And then what we're going to do is we're going to drop down a metaball, and then we're going to do a copy to points. Bring those in, and then we'll see what result we're getting. So to kind of break this down, without this, so if I were to just if I right click and disconnect this, we'll see that we're just getting a pretty uniform, even though it's random, we're randomizing this stuff, it's not quite as random as what this is. So we're getting a much larger value that's being pushed in here. So we got some smaller ones, we got some bigger ones, and one final time we'll just copy and paste this. We will change that scatter down to something like 5, so force total count being 5, and then we'll do is force the point is what we'll do here is we'll merge that in, and we can see overall it's just getting too big. So what we'll do is just change this down to a value of 0.5 and 1. We'll just give us a little bit more random results. So the bigger ones are in the middle. Great. So we have a good organic base mesh that we're starting with. And if we kind of come up here, we can kind of see the shape is starting to feel like a cloud. It's not so mechanical looking like what we were doing before. So now what we can do is start taking advantage of VDBs to create a really detailed noise pattern that goes through it. So what we'll do is we'll do VDB from polygons. Go ahead and plug that in. And we'll see that we'll get a little pixels again. If we want to see this as a fog, what we'll do is turn off distance, turn on fog, and then what we'll do is we're going to make this a pretty detailed setup of a voxel size. Again, in this case, smaller values mean more detailed. So I'm going to do 0.01. I mean, you can see how fast that was to create. And if I throw down an ISO offset, which is just going to use a standard Houdini volume, and if I set this uniform sampling to something like 100, we'll notice that it's going to take a few seconds to make. And on top of that, it's not going to be nearly as detailed as this. And we can even go higher, so like 150. And we're going to see that it's still not quite as detailed. And it's still cooking down here, so it's taking about 8 seconds. So it's about 9 seconds long to create that. And it's still just not as detailed, and it's not nearly as fast as a VDB. So long story short, whenever we're in SOPS mode, so this geometry level, and we're not doing simulation stuff, we want to try to stick with VDBs as much as possible. So I'll go ahead and delete this. And then what we're going to do is we're going to throw down a volume VOP, which is what we were using before, to create some more details. But we're going to use it in a slightly different way this time. So I'll do a volume VOP. I'll go ahead and plug this in. And this time, instead of sampling the density, what we're going to do is just do position and use that to create our noise. So we'll do AA noise. What we'll do is we'll switch this over to a 3D noise. And then we'll use position into position. Then we'll go ahead and add that on top of our original position. And if we try to output this, we're going to see that it's not going to work. And it's not going to work because it's essentially not a density volume. That's not what we want to do. Is take all these values, and if they're a value, return a value of 1. If it's not, it's going to return 0. And the way we do that is by a volume sample vector. So it's going to take this 3-way attribute and convert it down to a single density value that we can use. It's throwing an error. It's defaulting to put that into the file name, which we don't want. So by default, it's trying to actually bring in geometry. So what we'll do is we'll change the input over to first input, and then we'll do sum into sample position. So the position being the values that we have over here. And that's going to be the basic setup. So what we can do now is just start exposing stuff that we want to take advantage of, specifically with this AA noise. So we'll just go ahead and promote all of this stuff. So we'll right click here. A little bit difficult to see, so I'll just move this over so you guys can see it. So promote parameter right there, and I'll just go down the list and do that for each one of these. And again, what this is going to do is promote this parameter to the parent node so that we don't have to keep dive inside of this node. Cool. So to give some more detail here, what we can do is we can start essentially to just copy and paste this stuff. So I'm going to make 2 different setups. I'm going to rename this as our base noise. And then what we do is copy and paste this to make a more detailed version of this. And the primary control that we're going to use to create some noise to actually do more or less, what we can do is just go up and down on this amplitude. So the more we make here, the more details that we're going to see kind of shine through. So I'm just going to leave this on a value of 2. And then what we can do after this is just copy and paste this setup. And we'll go ahead and plug this back in. And then what we'll do is, whoops, I'll go ahead and unplug that and plug this into that. So now what we can do is start daisy chaining this stuff. So it essentially gets more and more detailed. So I'm just going to make sure that we offset the value at least something, because right now we're essentially applying the same noise pattern onto itself. So we're going to just make sure we do that. And then what we can do is we can either go up and down on this. So typically with the frequency, I like to, at least for these more micro details, just copy and paste this frequency, and I'm going to right click, paste relative references into the Y channel and the Z channel, so that way we can just control this right here. So now what we can do is if we go up, we can see it all happen at once. If we go down, we can see it all happen at once. And what I'm going to do is just make this a wide noise. So by pushing it to 0.5, what that's going to do is make these much broader strokes right here. So if we want to see the effects of that, we can just kind of go up on the amplitude. So I just put that to 5. So we're seeing that those pushed a lot heavier there. Cool. So we have a little bit of a problem. It's a little tough to see here, but you can see that we're actually getting these flat parts up here. That's because we're actually clipping our volume. So what we're going to need to do is we're going to need to expand these edges out. So before we go into the noise patterns, what we want to do is we want to throw down a VDB activate, and then we'll go ahead and throw this in here. And then what we'll do is we'll go over to expand, and then we'll go ahead and take these voxels to expand. So this is how many voxels we want to push it out. We'll set this to something like 50. And you can see, okay, now we have a much broader bounding box to work with. And on top of this, it's not really doing much in terms of slowing down in performance because remember, all these values out here are essentially coming in pretty cheap. They're not heavy like the. So if we were to do a VDB visualize right now, we'll see that we can still just see that it's not going to be pushing a lot of those values out there. So it's still pretty cheap. So we'll go ahead and check out our results again. So it should be helping us in terms of fixing that. So if I do this enable disable, you can see that those edges are now actually able to push out and get some noise on there. So we're not actually running into those issues anymore. You can see if I go back, if I disable this, we're getting a lot of the noise pattern in the middle, but as soon as it gets closer to the edges, it gets kind of cut off. Great. So if I go back to the wide noise, cool, we can see it's starting to feel really organic. And if I go in and throw in a light right now, so I'll just come up here and throw it on an area light. That's just to give my viewport some shape. So I just control click on the area light after I framed up the frame. And now we can see just in the viewport, we're getting a really detailed and a very organic looking setup. Great. So we need one last control with this setup before we actually switch it over to our start copy and pasting this around. What we can do is we're going to want a density control. So, excuse me, we'll do a volume VOP, and then what we'll do here is we'll just use this as our density control. So I'll just rename that to density. We're going to dive inside of there, and then what we'll do is do a volume VOP, a multiply constant. And we'll just go ahead and drag this over top of our VDB, and then essentially we now have a control over to this guy right here. Actually, I'm going to delete that because we're going to want to expose this. So I'll do just a standard multiply. I'll plug that in, and then what we can do is if we middle click down here on this input, what we can do is just do promote parameter. And it's going to shut off because it's going to default to a value of 0. So if we just come up here on the parent node and we just put this back to 1, it's going to be multiplying it by value 1, which is essentially 1 times anything is going to be just whatever that value is. So now we can actually start to multiply this up or down. So going up or down essentially is going to make it thicker and thicker. So the lower value you go, the more translucent it becomes. And you see up here we're actually getting some flat stuff happening, but that's okay. I'll just leave it there. Cool, so that's wrapping it up for this lesson. So what I'll do is just save this out as a chapter 5. We'll just call this VDB setup. So if you guys want to open that up and follow along, that'll be there.